Hello, today we will talk about Git VPN. But before we go through Git VPN, we have two questions from the last video. The first question is asking about, as you remember guys, we were talking about DMVPN in the last video. Today, someone is asking me, what if we have a failure in the hub, in the DMVPN? If the hub fell down, what will happen? So in order to configure another hub as a backup, yeah, we can do it easily. In this configuration, I imagine or I make this router act as another hub. The configuration is gonna be like that. On the interface, tunnel interface, I'm gonna give the IP address. This is the IP address, tunnel source interface, and GRE multi-mode, multi-point, IP and HRP ID, and multicast dynamic just for routing, split horizon as you see for the EIGRP, IP and HRP map. Here guys, I'm gonna map between what? I'm gonna map between the the hub tunnel interface IP and the real IP of the tunnel of the hub interface of the interface that's located on the hub router in the head office, for example. IP and HRP map multicast 192.1.10.11.1. And this is actually this is the IP of the hub, the main hub, because this is a secondary hub. So, and on the other hub, actually, or the main hub, what I will do, I will make the same. I will make the same here. On this is router 1, this is the hub. Actually, this is the first hub. You can say router 1 is the first hub and router 5 is the second hub. In this router, IP and HRP map, I'm gonna map between 1, 5, which is this is the tunnel interface IP for the secondary hub, and the real IP, which is 50.5. And here also as well, multicast, I'm gonna refer to the 50.5. On the clients or on the spokes, what I'm going to do, IP and HRP NHS 192.168.1.5, I'm going to refer to here, the NHS server is 1 and 5, so I have two NHS server right now. I have the first one which is 1.1 and the second one which is 1.5, and I will map as well between the tunnel interface IP and real IP of the second router. This is for the first question. The second question is someone is asking me about the, as you guys remember, the redirect and shortcut, the commands that we put on the hub. We put here redirect under the tunnel interface, and here we put a shortcut command. What it was for, as you remember guys, the journey of the backer, if for example, if this guy, he want to reach up here, he's gonna go through, or he will go first to the main or the head office or another location, and it will go to the second location, which is not really a practical thing. So we need him to go directly from this route. And as you guys know, when we configure this DMVPN here, when we configure the tunnel interface, under the tunnel interface we put a command of redirect. It means what actually? This router is gonna send him a message of redirection, and he, as shortcut, he's gonna receive it, and he will change the route. As you guys know, the NHRP actually has a full visibility for registration, because all the spokes is gonna register here, so this one has a full visibility of the routes. He knows the real IPs and the IP of the tunnel interfaces of each of the spokes, and he knows how it goes because it's translated in his table actually. This is for the second question. Today guys, we'll talk about Git VPN. What is Git VPN and what is used for? Git VPN is it considers it's IPsec VPN, but it's multi-site. Yes, but we cannot use it outside. We cannot use it in the public until we have a public IPs already. But it's the good solution if you have private IPs, because here in get VPN, the outer header and the inner header, it's not using the outer header, it's the inner header is used in the outer header as well. So get VPN, it is multi-site IPsec VPN. Use a single session key. What does it mean? Use a single session key. If you have multiple sites like that, the idea of get VPN is we will choose a one router or a one location. Head office, for example, this is head office is gonna be key server. This is a key server, and this will be member group number 1 and member group number 2. What does it mean actually? So this is gonna be like a server, and this location is gonna be like clients to the server. It's gonna every one of them, each one of them is gonna register himself in here in the key session, in the key server, and that is will give me the possibility of this will actually centralize first, will make two things, facilitate two things for me. The first one is it is gonna centralize the configuration, so I'm gonna do the configuration here, the key session. As you guys remember, the key session, the phase 1, it's gonna be configured in here on the key server, and it will be downloaded to the clients or the member group. What else, guys, will be configured here and it will be downloaded here? The SL, the interested traffic. So three things gonna be installed here, and it will be downloaded to the other. So there is no need to configure on each of the sites. So session key, the transport set, which is phase 2, and SL, which is the interested traffic. What one guy is asking me, key session and member group can be located on one router? No, it should be separated like that. And in something very important, guys, as you remember in IPsec VPN site to site, we were using as a CAMP port UDP port 500. In this get VPN, we are using GDOI UDP port 848. Okay, so let's go to the configuration and see how do we configure it. Here, guys, first I want to show you the topologies that I'm going to use to configure the get VPN. I have here 3 locations, as you see here. Location number 1, 2, 3, and here is the internet. So they as I said, it's private, so this is the net. You can say that this is a company, one company, okay, and they are having like MPLS, something internal connection between these 3 sites, site number 1, number 2, number 3. So I'm able to ping the 3 sites together. So I'm gonna configure the get VPN. I'm gonna configure the router 1 as a key server, and router 2, router 3 as a group member. I will do the configuration between the router 1 and router 2. Router 1 is gonna be key server, this group member, and number and router 3, guys, I'm gonna leave it for you. You can try to do it. So let's do it very quickly. I will go to router 1. What I will do, conf t crypto phase 1, guys, as you remember, crypto is account policy 10, encryption, authentication first, encryption, authentication, pre-share key, and hash 3ds. I'm so sorry. Hash MD5 and encryption 3ds. Group 2 exit, crypto, isocamp, key, Cisco 123, and address. The other address of the here, the address, a public address or realize outgoing address that is coming from here to here. This outgoing interface IP address here, 192 dot 168.20.2. This is the one. And after that, what I will do here, I will create the access list 101 permit IP 10.1.0. As you see, guys, here I have network. This is interested traffic. Actually, this is a private network, or you can say this is the traffic that I'm gonna encrypt, 10.1.1.1, and here the 10.1.2.2, and on the third location 10.1.3.3. So I will write an access list to define exactly what are the traffics that I'm gonna encrypt here. So access list 101 permit IP 10.1.0.0, and it will go, as you see in the other side, also is 10.1. 255.255, enter. And by the way, we configure the access list, the interested traffic. So what is the next step, guys? What we will do here, we'll configure what? Crypto, IPsec, transformer set. I'm gonna give it tset. I'm gonna give it a name. This is the second phase, ESP 3DS, ESP MD5. Here, guys, I'll create crypto or exit, crypto IPsec profile. I'm gonna give it a name, iProf. Then I will create IPsec, crypto GUI group. I'll give it name sales, for example. And under the group, what I will do, I will specify identity number. What is the identity number? 111, for example. Identity number 111. This identity number, it must be same on the other group member servers, because by the number actually the other routers is gonna come and register here, or they will know their key server router. And why I'm giving this number also, because we can use more than one number on key server. The key server itself can be key server for different groups. You can create different groups like sales, like HR, like IT, and whatever. So identity number here is 1111, enter. What else? I will say this is server local, enter. Server address, it will refer to himself. Server address IPv4, it will refer to himself on the outgoing interface 192.168.10.1, like that. What else we'll specify what else here. profile, we'll say profile iProf no. So configure group configuration, this will say match conft, sorry, crypto GUI group. We called it sales. Profile iProof match address IBv4 101. Okay guys, let's see something here. Show exit, show crypto, or show run section crypto. We have like crypto group sales. We have any other things? No, crypto GUI group sales and identity number, server local, and we give it this IP. So what? Crypto authentication, crypto as a camp key, transform set. We forgot one thing to do, guys, so I'll go back conft. Under the crypto map, crypto IPsec profile iProf set transform set. We didn't specify exactly. Set transform set and the name of transport set that we created here. Yeah, tset. Tset. Like that. Exit one more time. So we'll go back to the group. Crypto. GUI. Group. Sales. And what I will say here. Profile. iProof again. So match identity server and server identity 1111. No, sorry, identity number profile. Let's see, or let's see server local. Yeah, here I think profile iProf, even though. So errors default GUI I have to specify exactly what else here. We have to specify SA IPsec. SA IPsec 10. Yeah, and under that, on that IPsec SA security association, I will specify iProf, or sorry, profile iProf. Then what I will, the address we created, match address, yeah, here, match address 101 to trace the traffic of IPv4 101. And by the way, we finished that server. Now we'll go to the group member. In the group member conf-t, I'll configure phase 1 crypto ISACAM policy 10, then encryption, authentication, pre-shared key, encryption 3DS, hash MD5, and what else? Yeah, crypto ISACAM key, because yeah, I need the phase 1, but actually key Cisco 123 address 192.168.10.1. This is one. Actually, I forgot one thing, guys, to do. Crypto ISACAM policy 10 group 2. We finished phase 1. Here is the different things that we are gonna do now. This is actually, as we said, that this member group router is gonna take his session key from the main, from the key session server that we configured, which is router 1. Now router 2 is gonna take what is the difference between IPsec, normal IPsec VPN site to site, and this get VPN in the following steps. We'll configure GUI to point to the key server. So key crypto GUI what? Group. I'm gonna give any name, APC. Under it, the identity number, as you remember, it must be the same. And address or server address 192.168.10.1, which is the IP address of the key server, IPv4, like that. Yes, what else we'll write here? We'll configure the crypto map. Exit crypto map and give it any name, CMap, and under it crypto map CMap. What? Crypto map CMap 10 GUI, and under it, what I'm gonna specify here, set group, and the name of the group that I give it to a GUI APC. And under the interface itself, I will say interface gig, the outgoing interface, which this one here. It's 02. Crypto CMAP. Crypto map CMAP. Now guys, it's on. Now this group member is gonna register himself. If you go to router number 1 and say int show crypto map, what? Show crypto map what? Show crypto map GDOI SKS members. What you will find here? You will find that this one, which is 192.168.20.2, which this router, group member router, is register himself where here, and he got. We didn't configure as you see here the configuration on the router 2. Show running config section crypto. What do you see here, guys? You will see what is the different. Here I configured the phase 1 till here, but I didn't configure phase 2. I didn't configure the interested traffic because I'm gonna take, or I will get this information from what? From the key session. So if you have many sites, it's easy, it's efficient as well. So one more thing, guys, I want to talk about here. As you remember, in the phase 1, phase 2, each of them, they have lifetime, right? So what about the session key? The session key has a lifetime. Yes. Do you remember, guys, what is the lifetime of 3600 of the session key lifetime? That's great. So what if, as you see here, this is the key server. What if I installed one member group here? The lifetime of the session key is gonna be 3600. But what if after 5 minutes or 10 minutes I configure the other one, another group member router? Maybe this will be 3500. The remaining time, actually, because this came later. Came 10 minutes later than this one. So what will happen here? We need something. We need rekeying. We need the key itself to be generated automatically, instead of I'm waiting till the expiration time goes. So to configure the rekeying, guys, how do I configure the rekeying? I will come to the main, which is the key server, and I will do what? I will say crypto key generate RSA modulus 1024. I will generate a key and I will give it a label. Label is just a name. I'm gonna use it later, this label, get VPN, GET VPN, for example. The key is generated right now. Yes. Now I'm gonna use it where? I'm gonna use it under the GDOI. So crypto GDOI, crypto GDOI group. What is the name of that group? Sales. Yes. Enter. Now identity number, server local, rekey lifetime R, rekey sorry, server local identity number 1111, server local, I go to the server mode, then rekey under the server mode, rekey lifetime seconds 3600, and rekey authentication what? My public key, my pub key, RSA, and the label name get VPN. Enter. Rekey transport. We will transport it in unicast. Yeah, it could be transferred or transported in multicast. Yes, but in multicast, if you're gonna use multicast, you need something like PIM protocol enabled in your network, and because we don't have PIM right now, we are using unicast. Rekey algorithm. (3ds) like that. And this is the end of the video. See you next video. Thank you. See you.